Hi viewers, this is PHANIKUMAR, Senior Lecturer in Chemistry. Welcome back to our channel. In the last video, we discussed about the hybridization, rules for the hybridization, process of the hybridization and different parameters regarding the hybridization we discussed in the last video. Let's have a continuation of that topic. Today, let us discuss about the hybridization process in the ethylene molecule, acetylene molecule, water and ammonia, and what are the different parameters like bond strength and bond length and acidic nature depends on the hybridization, and if a molecule is given, how to determine the hybridization of the central atom in that molecule. That and all we are going to discuss in this video. Okay, without making any delay, let us come into our topic. So first of all, let us have a look on the hybridization in the ethane molecule. So we know that the ethane molecular formula is C2H6, and we know its structure. It is having like this. It is having one carbon sigma bond and 3 carbon hydrogen sigma bonds on each carbon atom, right? So merely by looking at the molecule, we can say the central atom in the process of hybridization I discussed yesterday. In the same way, let us discuss today also. Here the central atom is the carbon atom. What is the central atom in ethane molecule? Carbon atom. And what is its electronic configuration? 1s2, 2s2 and 2p2. If I represent the valency shell electronic configuration in the orbital diagram method, it will be like this: 2s2 and 2p2. So the carbon atom is having only 2 unpaired electrons in ground state. So it is having the ability to form only 2 sigma bonds in the ground state. But if you look at the structure, it is having 4 sigma bonds. So we have to take the first excited state electronic configuration. So the first excited state electronic configuration will be 2s1. One of the electron present in the 2s orbital is excited to the 2p orbital, and thereby in the 2p orbital we will get 3 unpaired electrons. In the first excited state, 1 2s orbital and 3 2p orbitals intermixes one with another to form 4 sp3 hybrid orbitals. These 4 sp3 hybrid orbitals forms the ethane molecule in each carbon atom. Let us take this is one carbon atom. It is having 4 sp3 hybrid orbitals. Then what happens? The sp3 hybrid orbital of one carbon atom overlaps with the sp3 hybrid orbital of another carbon atom to form one carbon sigma bond. One carbon sigma bond is formed over there. And then on each carbon atom we are having 3 sp3 hybrid orbitals. These are the 3 sp3 hybrid orbitals on this carbon atom. And in the same way, these are the 3 sp3 hybrid orbitals on this carbon atom. The sp3 hybrid orbital of the carbon atom overlaps with the s orbital of the hydrogen to form 6 carbon hydrogen sigma bonds. That means 3 carbon hydrogen sigma bonds on each carbon atoms. Right now, this is the formation of ethane molecule. And next, if you came, let's have a look in the hybridization of ethylene molecule. Ethylene molecular formula is C2H4. We know that it is an alkene and it is having 1 pi bond. It is having 1 pi bond. So the central atom should have at least 1 unpaired electron in the pure p orbital. Now, the ground state electronic configuration of the carbon atom is 1s2, 2s2, 2p2. The first excited state electronic configuration will become 1s2, 2s1, 2p3. If I represent this valency shell in the orbital diagram method, it will be like this, right? Are you clear? Now, I told ethylene molecule is having one pi bond, so it should have one unpaired electron in the pure p orbital. So what happens? One 2s orbital and two 2p orbitals intermixes one with another to form 3 sp2 hybrid orbitals. How many hybrid orbitals are formed? 3 sp2 hybrid orbitals are formed over there. So now the sp2 hybrid orbital of one carbon atom overlaps with the sp2 hybrid orbital of another carbon atom to form one carbon-carbon sigma bond. And after that, we are having two sp2 hybrid orbitals with the unpaired electron on each carbon atom. In each carbon, you are having two sp2 hybrid orbitals. They overlaps with the s orbital of the hydrogen to form 4 carbon hydrogen sigma bonds. Like this, you will be having 2 hydrogens on each carbon atom. And after that, here you are having one unpaired electron in the pure p orbital. One unpaired electron is there in the pure p orbital. So the pure p orbital, which is having an unpaired electron, overlaps laterally or in the sideways fashion to form one pi bond. So ethylene molecule is having one pi bond. This is what about the structure of ethylene. And next, let us come for the acetylene. We know that the molecular formula is C2H2, and as acetylene belongs to alkyne, it is having 2 pi bonds. It is having how many pi bonds? 2 pi bonds are there in the acetylene molecule. Now what happens? Ground state electronic configuration as usual, 1s2, 2s2, 2p2. First excited state electronic configuration in the valency shell will become 2s1, 2p3, and in orbital diagram method, it will become the electronic configuration. So as it requires to form 2 pi bonds over there, here how many pi bonds has to be formed? 2 pi bonds. So what happens? 2 p orbitals does not involve in the hybridization process. So one 2s orbital and one 2p orbital involves or intermixes one with another to form 2 sp hybrid orbitals. Then what happens? The sp hybrid orbital of one carbon atom overlaps with the sp hybrid orbital of another carbon atom to form a carbon-carbon sigma bond. And the second sp hybrid orbital of one carbon atom overlaps with the s orbital of hydrogen to form one carbon hydrogen sigma bond on each carbon atom. Totally 2 carbon hydrogen sigma bonds are there. After this, you are having 2 pure p orbitals. After this, what you are having? 2 pure p orbitals. The pure p orbitals overlap in the sideways fashion to form 2 pi bonds. Like this, the acetylene molecule is having 2 pi bonds. This is what about the structure of acetylene molecule. Are you clear? Have you looked at these structures once? Okay, now let us discuss about the hybridization in ammonia molecule. We know that the molecular formula of the ammonia is NH3. Here the central atom is nitrogen. So it belongs to which group? you know that it belongs to 58 group. So the valency shell electronic configuration is NH2 NP3. So in orbital diagram method, this will be the electronic configuration. So mainly by looking at the molecule, you can say the nitrogen is bonded to 3 hydrogens. So it need to form how many sigma bonds? 3 sigma bonds. And it is having how many unpaired electrons? 3 unpaired electrons. So what happens? It undergoes sp3 hybridization. 1 s orbital and 3 p orbitals involved in the hybridization process. So it undergoes sp3 hybridization, and the 4 sp3 hybrid orbitals overlaps with the s orbital of hydrogen to form ammonia molecule. But the molecule is having pyramidal shape. The shape of the ammonia molecule is a pyramidal shape, and it is having the bond angle 107 degrees. How much bond angle will be there? 107 degrees. Actually, if sp3 hybridization takes place, the bond angle should be 109 degrees 28 minutes. But in ammonia molecule, the bond angle is reduced from 109 degrees to 107 degrees. That is because of the presence of this lone pair of electrons on the nitrogen atom. So the deviation in the bond angle will be discussed in detail in the PSVPR theory, valency shell electron pair repulsion theory, and this will be the structure of ammonia molecule. And in ammonia, the nitrogen is having a lone pair of electron. So ammonia is having 1 lone pair and 3 bond pairs. Next, in the same way, if we have taken water molecule, the central atom is oxygen. Oxygen belongs to 68 group. So its valency shell electronic configuration is NH2 NP4. In orbital diagram method, the electronic configuration will be like this. So it need to form how many sigma bonds? 2 sigma bonds with the 2 hydrogen atoms. So it is having already 2 unpaired electrons, no? So it undergoes sp3 hybridization. That's what I told in the rules for the hybridization. Hybridization involves the atomic orbitals either completely filled or half filled, or what we can say, vacant orbitals. All the 3 kinds of orbitals can be involved in this process, right? Now here what happens, the 2 sp3 hybrid orbitals with unpaired electron overlaps with the s orbital of hydrogen to form the water molecule. After that, the 2 lone pair of electrons are present in the oxygen atom. Because of these 2 lone pair of electrons, the bond angle will be around 104 degrees. So the deviations in the bond angles of the ammonia and water molecule from 109 degrees to some other will be discussed in detail in the VSEPR theory. This is what about the structures of the molecules based on the hybridization. And if we discuss about different parameters, what is that? What is the bond strength according to the hybridization? So if a sigma bond is formed by the overlapping of 2 sp3 hybrid orbitals, that will be a strong bond. After that, sigma bond formed by the overlapping of 2 sp2 hybrid orbitals, and then 2 sp hybrid orbitals, right? And then between p and s, pp, sp and ss. This is the bond strength order according to hybridization. Bond strength order according to the hybridization. Next, in sp3d hybridization, the most important points for the competitive examination. In sp3d hybridization, we are having 5 degenerate orbitals in the d orbital, right? So which d orbital is involved in the hybridization process? In sp3d hybridization, dz square orbital participates in the hybridization process. Which orbital participates in the hybridization process? In sp3d hybridization, dz square orbitals involves in the hybridization process. And next, in sp3d2 hybridization, then dx square minus y square orbital and dz square orbitals participates in the hybridization process. Next, in sp3d3 hybridization, the same dx square minus y square, dz square and dxy orbitals are involved in the hybridization process. These are the most important points for the different competitive examinations. And next, if you want to discuss about the bond length, here bond length is directly proportional to the percentage of p character. Okay. Next, bond length is inversely proportional to the percentage of s character. Okay, bond length is directly proportional to percentage of p character. Bond length is inversely proportional to the percentage of s character. Next, another important point, most important point you have to remember, that is electronegativity. Electronegativity of the central atom is directly proportional to percentage of s character. How we will get the question based on this? For example, here I have discussed today ethane, ethylene and acetylene molecules are given. In this, identify the most acidic compound he will ask. Simply we can say acidic nature is directly proportional to the electronegativity. Here I told electronegativity is directly proportional to percentage of s character. We know that in ethane which hybridization is there? sp3. Here which hybridization is there? sp2. Here which hybridization is there? sp. If we come for the percentage of s character, in sp3 the percentage of s character is only 25%. The percentage of s character is 25%. Here the percentage of s character is 33.33%. Here it is 50%. So acetylene is having more percentage of s character. So it is having more electronegativity. So acetylene, right friends. So another important question here we are having is find the number of pure and hybrid orbitals in the given molecules. Here I will explain two different examples for you. What are they? Let us take benzene. So what is the molecular formula of the benzene? It is nothing but C6H6. You know the structure of the benzene. This is the structure of benzene. It is having 6 carbon atoms and each carbon atom is sp2 hybridization. Right, sp2 hybridization electron pair number 3. We know that already we discussed in the last video. So number of hybrid orbitals is equal to electron pair number into number of atoms with that hybridization. Right, now you can see electron pair number for the sp2 hybridization is 3 into how many atoms are with sp2 hybridization? 6. So totally you are having 18 hybrid orbitals. And in the same way, number of pure orbitals is equal to 2 into number of pi bonds, 2 into number of pi bonds plus number of hydrogen atoms, number of hydrogen atoms. Right. Now here, how many pi bonds are there in that molecule? You are having 3 pi bonds. So 2 into 3 plus 6 hydrogen atoms. So total 12. So it is having 18 hybrid orbitals and 12 pure orbitals. The ratio of hybrid orbitals and pure orbitals will be 18 is to 12. That means 3 is to 2 we can write. In the same way, I will give you another molecule like this: CH, triple bond, C, CH, double bond, CH, CH3. This is the molecule given. In this molecule, he will ask what is the kind of hybridizations present in that molecule and find the number of hybrid orbitals and pure orbitals. Now, triple bond is there. So, the first carbon atom, here the first carbon atom is having a sp hybridization. The first carbon atom is having sp. And this is also having a double bond now, 2 pi bonds now, sp hybridization. So hybrid orbitals number is equal to, you are having 2 sp hybrid orbitals. So 2 into electron pair number of sp hybridization is 2. So 2 into 2 plus, here these 2 carbon atoms are having only 1 pi bond. So 2 into, these 2 carbon atoms are having sp2 hybridization, right ma? Now 2 into sp2 hybridization means electron pair number 3, 2 into 3 plus only 1 carbon atom with sp3 hybridization. So 1 into 4. 2 2's 4, 2 3 6, 6 plus 4 10, 10 plus 4 14 hybrid orbitals are here in this molecule. And the pure orbitals number is equal to, how many pi bonds are here in this molecule? 1, 2, 3, right? 3 into 2 plus how many hydrogens are in this molecule? 1, 2, 3 plus 3, 6. So totally 12 pure orbitals will be there. So I will give you another molecule. You please try to find the number of hybrid orbitals and pure orbitals in this molecule. Okay, will you do it? Try to do it. CH2 double bond C, double bond C, CH double bond CH, CH3. This is the molecule. For that molecule, you try to find the hybridizations for each carbon atom and the ratio of number of pure orbitals and the hybrid orbitals. Please note down this molecule, my dear friends. Now, let us discuss about the methods of calculating or finding out the hybridization of the given molecule. We can use different methods. In this class I am going to discuss about 4 or 5 methods for the determination of the hybridization of the central atom. So you just practice all these methods. Whatever the method you find easy and simple, that method you just use to find the hybridizations, right? So what is the first method? So in all these methods, before going to these, let me tell you, we can find the hybridization based on the electron pair number. Okay, so here we are having different kinds of hybridizations and already we discussed. So if the electron pair number of a central atom we got 2, that is sp hybridized, 3 sp2 hybridized, 4 sp3 hybridized, 5 sp3d hybridization, 6 sp3 due to hybridization. 7 if we got the electron pair number, the hybridization will be sp3d3 hybridization, right now? So you have to remember these values. If electron pair number is 2, sp, electron pair number is 3, sp2, electron pair number is 4, sp3, electron pair number is 5, sp3d, 6, sp3d2, 7, sp3d3. Now let us discuss about the first method for the determination of hybridization, right? Now if a molecule is given for you, what we have to do or what you have to do for the determination of hybridization? Simply, after looking at the molecule, you find the central atom in the given molecule. The first point and the simple one, you can do it. Find the central atom in the given molecule first. Second one, you have to calculate the number of valency electrons. You have to calculate the number of valency electrons in the central atom. First, find the central atom. Second, find the number of valency electrons in the central atom. For example, if the element belongs to 13th group or 3A, third A group, the number of valency electrons is 3. 14th group or 4th A group, valency electrons is 4. 15th group or 5th A group, valency electrons is 5. 16th group or 6th A group, valency electrons is 6. 17th group or 7th A group, 7. 18th group or 8th group, that is inert gases, the valency electrons number will be 8. Okay, after that what you have to do? You have to calculate the number of monovalent atoms. What you have to do? Calculate number of monovalent atoms. Calculate the number of monovalent atoms. Let me represent these monovalent atoms with M. So here the monovalent atoms are only two kinds of atoms. So you need not to worry about that. Either hydrogen or 7th A group elements. What are 7th A group elements? Fluorine, chlorine, bromine, iodine. Right. These will be the monovalent atoms. Calculate the number of monovalent atoms. And you have to calculate the electron pair number. After that, you have to calculate the electron pair number. How to calculate the electron pair number? Here you are having three different formulas. For neutral atom, for anion, and for cation. Almost all are having similar, only differs in the magnitude of the charge. Electron pair number for the neutral atom is calculated by the formula half into V plus M. What is V here? Number of valency electrons. V is number of valency electrons. What is M here? Number of monovalent atoms. If anion is given, then the formula will become half into V plus M. As it is having negative charge, you have to add plus C. Here C is the magnitude of the charge. If cation is given, half into V plus M minus magnitude of the charge. Simple one. Now let me explain an example. NH3. He asked you to find the hybridization in NH3 molecule. First of all, what is the central atom in this molecule? Nitrogen. Nitrogen belongs to which group? 5th A group, right? So its valency is 5. How many monovalent atoms are here? 3 hydrogen atoms. So find the electron pair number. Half into 5 plus 3, that is 8 by 2, 4. 4 means which hybridization? sp3 hybridization. It is here. Right? I will give you another example. That is NH4 plus, let me take here half into nitrogen only the central atom 5, number of monovalent atoms 4, positive charge is here, it is a cation, so plus 1 charge, so minus 1, so 8 by 2 again 4, so the same sp3 hybridization. Let me take another example. NO3 minus half into group number of nitrogen central atom 5 plus, is there are any monovalent atoms? Oxygen is divalent. I told only hydrogen and halogens you have to consider. So 5 plus 0. As you are having minus 1 here, plus 1. So 6 by 2, 3. 3 means which hybridization? sp2 hybridization. Are you clear? So in this process, I will give you some work. Please try to solve it. Definitely you will get it. So what are they? Find the hybridization in H2O molecule. Oxygen hybridization you have to find. SF4 molecule and XeOF4 molecule. Right. Next in the same way. XeF6 molecule. Right. Next in the same way. SO4 minus 2 molecule. NO2 minus molecule. ClO4 minus molecule. Like this, for all of these molecules you try to find the hybridization. Simple, what you have to do, in all of these you have to identify the central atoms. Here the central atom is oxygen, here it is the sulfur, here it is xenon, here sulfur, here nitrogen, here chlorine. Already you know the group numbers, here I gave. Number of monovalent atoms, you have to consider only the hydrogens or halogens. If minus charge is there, adding. Positive charge is there, subtracting. Using this, easily you can calculate the hybridizations of these molecules. This is first method. You just note down these molecules once and solve. Right? Will you do it? Do it. Let us discuss about the second method for the identification of the hybridization of central atom. Right? So same, what you have to do in this method also, you have to find the central atom. The first point, everywhere it is the common. Find the central atom and find the number of valency electrons in that central atom. That is the first point. Second one, in the first class we discussed, write the Lewis dot structure for the given molecule. Write the Lewis dot structure for the given molecule or ion. After drawing the Lewis dot structures, calculate the number of bond pairs and number of lone pair electrons. What you have to do? Calculate the number of bond pairs or number of lone pairs in the given molecule or ion. Simply, the sum of bond pair electrons and lone pair electrons, the sum of bond pair electrons and lone pair electrons will become the electron pair number. Right? Simple. 4 steps. Central atom, find its valency electrons, draw the Lewis dot structures, calculate the bond pairs and lone pairs, and the sum of bond pairs and lone pairs will give the electron pair number. Based on that you will get the hybridization. Let us have a simple 3 examples. Ammonia. Central atom is nitrogen and its Lewis dot structure will be like this. So merely by looking at the structure you can say it is having 3 bond pairs and 1 lone pair. So the electron pair number will be 4 and its hybridization will be sp3 hybridization. In the same way, let us take water molecule H2O. Oxygen is the central atom. Right? 2 bond pair electrons and these 2 are the lone pair electrons. The sum will be 4. the hybridization will be sp3. In the same way, I will give you some other example, that is SO4 minus 2. Here the central atom is sulfur and it is having two double bonded oxygen atoms, minus, minus. This is the sulfate ion structure. How many bond pairs are there around the sulfur atom? 1, 2, 3, 4, 5, 6. How many sigma bonds? You have to calculate only the sigma bonds around the central atom. How many sigma bonds are there? 4. So 4 bond pairs, 0 bond pairs. 4. So the hybridization will be sp3 hybridization. This is the second method and simple method, right? Have a look at this. So let us discuss about third method for the identification of the hybridization. Okay. So what is that mean? Simply that is also based on the electron pair number only. How to calculate the electron pair number means, if a neutral atom is given, this you have to remember. If a neutral atom is given, electron pair is equal to, here, number of bonded atoms. They may be monovalent, divalent, that and all unnecessary for us. It is in easy and important formula. Number of bonded atoms plus half into group number of central atom. Half into group number of central atom. Right? Minus number of valency electrons involved in the bonding. Number of valency electrons involved in bonding. This is the simple formula. Right? What is the formula? Electron pair number is equal to number of bonded atoms plus half into group number of central atom minus number of valency electrons involved in the bonding. So let me take the simple example, ammonia. Right? Electron pair number is equal to, how many bonded atoms are there for the central atom? 3 hydrogens. 3 plus half into group number of nitrogen. I told 58 group. So 5 minus 58 group valency is 3. Already I told you in the second method. 5 minus 3. So 4. Though it is having sp3 hybridization. Right? Next, if a cation is given, then what happens? Simple one. Electron pair number is equal to number of bonded atoms plus half into group number of central atom minus number of valency electrons involved in the bonding. If cation is given, minus magnitude of the charge. Minus magnitude of the charge. Simple. Let me take a cation, ammonium ion over here. Right? NH4 plus. Simple one. Electron pair number is equal to number of bonded atoms. How many bonded atoms are here? 4. Plus half into, what is the group number of nitrogen? 58. 5. What is the valency? With how many atoms it is attached? 4. Next, what is the magnitude of the charge? +1. So, write -1 here. So, the electron pair number is 4 and the hybridization will be sp3. In the second method, next, in anion, same formula. Electron pair number is equal to number of bonded atoms plus half into group number of central atom minus number of valency electrons as anion is given plus magnitude of charge. So already in the second method I described about SO4 minus 2. Now let me take NO2 minus. right? How many bonded atoms were here? 2 oxygen. So 2 plus half into, what is the group number of nitrogen? It belongs to 50 group. 5 minus. What is the valency of nitrogen? In the first day itself we have described, that is, the valency of an element with respect to oxygen is equal to twice the number of oxygen atoms with which it attached. So 2 oxygen atoms are there, so its valency will be 4. So here you are having minus 1 charge, so plus 1 use over here. Then what happens? 6 minus 4, that is 2. 2 by 2 means 1. The electron pair number is 3. So it undergoes sp2 hybridization. Have a look at this and note down the formulas. Now let us discuss the fourth method for the calculation or identification of the hybridization of central atom. Simple. Here what you have to do, you have to count the total number of valency electrons, of all the atoms involved in that molecule, of all the atoms in molecule or in the ion. All atoms are in the molecule or ion. You have to calculate the total number of valency electrons, and if you got that number is represented as V, let us represent that number as V. If you got the V value, the number of valency electrons value greater than 8, if you got greater than 8, then divide that V with the 8. Divide that V with the 8. If you got 0 as the remainder, it is okay. If you don't get the remainder 0, then the non-zero remainder divide with the 2 to get the electron pair number. Then if remainder is not equal to 0, divide that remainder with the 2 to get the electron pair number. Now the formula for electron pair number will be quotient plus remainder by 2. Quotient plus remainder by 2. If the second case, if the V value is less than 8, if you got the total number of valency electrons less than 8, then what happens? Divide that V value with 2 to get the, what we can say, electron pair number. Simple. Now let me explain few examples. Let me take PCl5, right? So here we are having phosphorus. Phosphorus belongs to which group? Nitrogen group, that is 50A group. So its valency electrons is 5. Plus, how many chlorines are there? 5. Chlorine belongs to which group? 7A group. So 40. The V value is 40. So it is greater than 8, no? Divide it with 8. 40 by 8 means how much? 5. So the remainder is 0. So Q value is equal to the electron pair number. So the hybridization is sp3d hybridization. Next, let me take another example, BeCl2. We know that beryllium belongs to which group? 2A group. So 2 valency electrons plus 2 into 7. So 2 7s 14 plus 2 16. So the V value is greater than 8. So divide it with the 8. Then what you will get? 16 by 8, 2. So the remainder is 0. So its hybridization will become sp hybridization. Next, another example, BF3 molecule. Let me take. Here, boron belongs to which group? 3rd group. So 3 plus 3 into 7. Fluorine belongs to 7th group. 21 plus 3, 24. Greater than 8. So divide it with 8. So 24 by 8, 3. So the remainder is 0. So what happens? It belongs to sp2 hybridization, right? The last example, both 3 I have considered, right? So 3 oxygen atoms and oxygen belongs to 68 group. So 3 into 6, 18 I got. So we don't get 0 remainder. If I divide 18 with 8, it is greater than 8. So V is greater than 8. So divide it with 8. If I divide, what happens? 2 times 16. 2 is the remainder. And then what you have to do? This will become the quotient. Okay, that will become the quotient. And divide this 2 with again 2. Then you will get remainder 0. Here the quotient is 1. So what happens? The electron pair number is equal to, here the quotient 2 plus here the quotient 1. 2 plus 1, that's equal to 3, and the central atom of the ozone molecule is having sp2 hybridizations. Okay, these are the different methods for determination or identifying the hybridization of the central atom. So enjoy your learning. Thank you for watching.